Good afternoon. My name is Josh Frye, and I, along with my partner Eric Nichols, will be walking you through a case study of the Ford Motor Company and their integration of the SAPI model for continuous improvement. For this presentation, we'll be discussing a brief history of the Ford Motor Company. We'll have a high-level overview of the SAPI model, and then we'll talk about each of the 15 steps within that model as they apply to the Ford Motor Company, specifically their F-150 pickup truck. After we've gone through the model, we'll discuss recommendations and conclusions going forward. From the humble beginnings of a workshop garage, Henry Ford founded the Ford Motor Company in 1903. From the day of its founding up until today in 2015, Ford has been one of Detroit's big three automakers for the domestic U.S. market. Currently, Ford is an industry leader, with vehicle sales totaling close to 2.5 million in both 2013 and 2014. More specifically, the F-150 pickup truck has sold 750,000 sales vehicles in 2014 alone. A large part of the success of the Ford Motor Company can be attributed to adopting the continuous improvement methodology. Today, Ford practices such ideals as Lean Six Sigma, total quality management and leadership, and the PDCA cycle: plan, do, check, and act. The SAPI model, or the Systems Approach to Process Improvement model, is a process improvement model that focuses very strongly on stakeholders and operational definitions. In order to make the 15 steps of the SAPI model more digestible to the common user, it's segmented into 3 significant steps. Steps 1 through 3 can be called the significant stakeholder requirements. Steps 4 through 11 are the organizational improvement efforts, and steps 12 through 15 are supplier requirements. For the rest of this case study, we're going to be walking through the Ford Motor Company, more specifically their F-150 pickup line, and apply this model step by step to see what recommendations we could make for the future and evaluate if we think Ford has truly adopted this model of continuous improvement.
So as Josh mentioned, the SAPI model is broken up into 3 distinctive sections. The first one being significant stakeholder requirements. And as he mentioned, we're going to be putting ourselves in Ford Motor Company's shoes and essentially walking through a year of process improvement that Ford might take to improve their F-150 platform. So first of all, step 1 in the SAPI model is they need to identify and prioritize their stakeholders. Then they need to find out what those stakeholders' needs and wants are, and then develop operational definitions for producing quality characteristics. So when it comes to identifying those stakeholders, there's a number of internal and external stakeholders. One being a primary customer, they're the end user. They're going to be the ones that are driving and owning the vehicle. There's the EPA, that's essentially the United States government Environmental Protection Agency. They have a number of requirements that they must meet from an environmental standard. And then there's the suppliers, for instance. They interface directly with Ford and provide the base materials that go into the Ford F-150. So when it comes to, what does the customer actually want? For instance, they want a truck that's, 1, fuel efficient. It's got to be reliable. It's got to last a long time. And it's also has to be safe. What does the EPA want? Ford needs to make a truck that meets emission requirements. It needs to meet sound requirements. It can't be too loud. That's especially in terms of the exhaust. And then what do suppliers want? Well, they want a mutually beneficial relationship with Ford. They want consistent order book. They want good communication, and they want reasonable pricing agreements for the material that they're providing. So how does that translate into quality characteristics that Ford understands? Well, taking a look at the primary customer, when it comes to customers wanting a fuel-efficient vehicle, what does that mean? Well, they need They need a truck that's able to produce a high, essentially a low fuel consumption rate, which means that's a high miles per gallon vehicle. When it comes to what the EPA wants, they want they have certain sound requirements that the vehicle needs to meet. Well, that means that the Ford F-150 needs to have a low decibel output in terms of sound. And essentially for suppliers, they want reasonable pricing agreements for material, and that translates directly into money. The next section of the SAPI model is organizational improvement efforts. So that's steps 4 through 11. So we just mentioned the some quality characteristics on the last slide. One in particular that we're moving forward with is the primary customer's needs of a fuel-efficient vehicle, and that translates directly into the quality characteristics of a high MPG is what they need for the truck. So how does Ford affect miles per gallon as an organization? Well, there's a number of ways of doing that. There's looking for ways to affect driver behavior, reduce the curb weight. Essentially, that's looking for potentially other materials that might be lighter. Most trucks use steel. Ford could look into lighter materials such as aluminum and essentially replace all steel areas of the body panels. They could reduce the size of the engine. Instead of a big V8 or even a V6, they could look into a fuel efficient 4-cylinder, maybe turbocharged, while still regaining some of that power lost. They could look at improving combustion design, transmission design, and also aerodynamics. A lot of trucks are not always the most aerodynamic of shapes, so they could look for improvements there. So at the end of the day, we're going to take a look at, okay, Ford needs to reduce curb weight for their F-150. That might be a big lever that they can easily pull to affect MPG as an organization. So in the next slide, we're going to talk about how we're going to develop operational definitions for producing those quality characteristics. So from step 4, we identified some quality characteristics that we can affect that would in turn affect miles per gallon and increase that essentially the range of the F-150. But if we were to make those improvements, reducing curb weight, how would we know that we've improved? Well, we need to develop operational definitions for producing those quality characteristics. So one area that we could do that is essentially define criteria, a test that we could use to essentially prove that we've met that criteria. And then we'd have a decision point whether if we did or did not meet that criteria, what will we do next? So in the case of reducing curb weight and affecting miles per gallon, for criteria, we need a percent improvement. So let's agree on a percent improved MPG should be greater than or equal to 30.6%. This is essentially reflective of the 2015 CAFE fuel standard requirement that all trucks need to have a miles per gallon of about 23.5 mpg. That's a tough goal to hit, and that's something that Ford's going to have to work to, since in 2014 their combined mpg was around 18. Excuse me. So that's their goal, 30.6% between 2014 and 2015. That's a huge undertaking. So if they were to go forward with those improvements, with shedding that weight, how would they test it in the end? So the Environmental Protection Agency has a standardized federal test procedure that essentially all manufacturers, all car manufacturers need to run their various truck and car platforms through, which is essentially a mix of various operating conditions that help to determine a resulting MPG rating for that vehicle. So that's what they would use to test their vehicle, test their changes, and check it against the criteria that we just defined. So once they got that resulting MPG output, they have a decision to make. So if the resulting MPG should be compared against the industry standard, if it's not met, it needs to be improved for the subsequent model year. So, as I mentioned, that 30.6 improvement is required between the 2014 and 2015 model year to meet those industry standards. Moving right along in the SAPI model, we're on to step 6, where we're identifying process within which quality characteristics are produced. So we're moving forward with the idea of reducing body weight. Where does that reside within the Ford F-150? Well, shedding weight, we could take a look at the vehicle frame, vehicle body, the powertrain, interior components, and exterior accessories. So we're going to look and do a deep dive and perform a fishbone cause and effect diagram for the vehicle body.
Now that we've narrowed down to the vehicle body as the process that helps contribute to a large curb weight, it's time to move on to step 7, develop knowledge of the process. Said another way, what contributes to such a high curb weight in the process of building the vehicle body? A good way to map this out is to use a fishbone diagram or a cause and effect diagram. By concentrating on the 6 M's of man, machine, method, material, measurement, and Mother Nature, we can categorize all of the potential causes that lead to the effect of high vehicle body weight. Of these causes, one should consider what we truly have control over and what would really influence this outcome the most. And for the purposes of this case study, we've narrowed into the material side, saying that the steel alloys, the glass, and the fasteners, all within the body panels themselves, add significant weight to the vehicle body. After developing knowledge of a process, it's important to see if that process can achieve stability and capability in the output quality characteristic that you've defined. Now, for this specific example, we don't have minute data of either body panels or curb weight from a sample of data. However, we do know the spec listing for each model year, as shown in the graph on the chart. So you can see that between 2000 and 2015, there are a few variations in what the curb weight is, both the minimum and the maximum, based on introductions of new body styles in 2004, 2009, and then in 2015. This is a bit of jumping to the result, but in 2015 data, you can see that Ford has taken all of their steel panels for the body of the F-150 and converted it into aluminum, thus proving that they've got a stable and capable process of reducing weight. After narrowing this scope down to vehicle curb weight, and even further to say that the body panels on the Ford F-150 contribute a significant amount to the total curb weight, we then move on to step 9, translating that output quality characteristic into a process quality characteristic. For this effort, we've selected the specifications themselves on body panel size as being a contributing factor. Length, width, different material strength properties that might be called out in specification are all well maintained in a process that could contribute to the final value of weight. Moving on to step 10, there needs to be a development of operational definitions for these characteristics in order to ensure that everyone's speaking the same language, communicating effectively to one another, and create a producible and repeatable process. For step 11, achieving stability and capability in that process quality characteristic, we would typically create a run chart or a control chart to show whether or not current capability is within specified limits. As we don't have any data from Ford ourselves, we did some research and found information from a University of Michigan study based around sheet metal stamping for automobile doors. Although they did not specify a corporation, we can assume that the same types of errors found in this study might be present in Ford, and they would have to do something very similar to achieve completion of step 11.
For the third and final section of the SAPI model, we're looking at supplier requirements. Essentially, we're looking at ways to improve the supply chain through process improvement. For step 12, we're looking at identifying those requirements for process inputs. Essentially, we're looking at requirements such as on-time delivery. That's a very important requirement, which is not just important to Ford, but to the end user stakeholder and to dealerships that are trying to sell vehicles, meet their own deadlines, make sure they have a fully stocked inventory. That way they can provide a selection to the end user. So on-time delivery requirements, those need to be communicated in step 13 to the supplier. And in 14, we need to develop operational definitions for those input quality characteristics. In particular, when it comes to on-time delivery, there might be the requirement for the supplier to have a 95% on-time delivery rate in 2015. If they're unable to make that, they most likely would keep the same 95% for 2016. But if they're able to achieve that for 2016, they might bump it up a percent. Always looking to improve. For the 15th and final step of the SAPI model, Ford needs to ask their suppliers to perform steps 4 through 15 themselves, essentially performing organizational improvement efforts while identifying and working with their own suppliers to look inward and identify improvement opportunities. So in the end, Ford, along with their suppliers and the suppliers need to always continuously improve, satisfy the stakeholders, and reevaluate their priorities constantly.
After completing this case study, we found that Ford F-150 has room for improvement in achieving a fuel efficiency level that would satisfy their end customers. On that note, we'd recommend that Ford would find a way to reduce the overall weight of their F-150 model pickup truck to help satisfy that requirement. As it turns out, in 2015, Ford did just that. They switched many of their steel panels in the body of the truck to aluminum, significantly reducing weight, approximately 700 pounds averaged across all the different models they produce. It also showed a significant fuel efficiency gain in isolation, and additionally, there are several other engine options using technology such as turbochargers and just smaller overall size to help boost efficiency as well. In conclusion, Ford is clearly using a model, if not identical to the SAPI model, very similar, and they've been achieving continuous improvement in making a higher quality product to satisfy their customers. Thank you for your time.